Hello guys, welcome to Dilk Learning. In this channel, we simplify chemistry especially for plus 1 and plus 2 students. So today's topic, electrolytic versus electrochemical cell, one of the most confusing concepts. Let's make it crystal clear here. Electrochemistry is one of those chapters where everything looks similar. Anode, cathode, oxidation, reduction. One small confusion can flip your entire answer. Today, we fix that in the simplest way possible. First of all, let's define electrochemistry. Electrochemistry, the name itself has two components, electrical and chemical. So, electrochemistry is actually the study about the interconversion of electrical energy and chemical energy. It is the study about interconversion of electrical energy and chemical energy. So, chemical energy can be converted into electrical energy. Similarly, electrical energy can be converted into chemical energy. In the first case, we carry out spontaneous chemical reaction. As a result, energies are released. The energy is used to produce what? Electricity or electrical energy. This is actually what happening in electrochemical cell, the batteries, the cell we use in our daily life. This is what happening in electrochemical cells. Right. And the second case, we use electrical energy to carry out non-spontaneous chemical reaction. Since the reactions are non-spontaneous, we have to supply an energy externally. So for that purpose, we use electrical energy. We use electrical energy and we convert it into what? Chemical energy. That is, we carry out non-spontaneous chemical reaction. We are familiar with electrolysis. We use electricity for lysis, that is splitting of compounds. So electrolysis, electroplating all come under this category. Electrolytic cells, we call it as electrolytic cell. Clear? So whether it is electrochemical cell or electrolytic cells, there are two major components that are electrode and electrolyte. Electrode and electrolyte. These are the two major components of every electrochemical system. These are the two core components. Okay, so what is an electrode? It is a solid conductor, usually a metal, and it allows electrons to enter or leave the system. So electrode means it conducts via the movement of electrons. Okay, in electrodes, the conduction is due to the movement of electrode. And electrolytes are ionic solution. Ionic solution or molten salt means it is in liquid state, right? Ionic solution or molten salt. If NaCl, we are taking NaCl, we can either dissolve it in water and a solution we get, or we can use what? Molten NaCl itself. So electrolytes are ionic solution or molten salt. It allows ions to move between electrode completing the circuit. Thus, in electrolyte, the conduction is due to the movement of ions. In electrolyte, the conduction is due to the movement of ions. Electrode, it is due to electrons, and electrolytes, it is due to ions. Clear? So electrodes are of two types, and first one is anode and second one is cathode. First one is anode and second one is cathode. Anode is the electrode where oxidation occurs, whereas cathode is the electrode where reduction occurs. You can remember it like that. An ox, red cat. An ox, red cat. Imagine the picture of an ox and a red cat. Thus you can write at anode oxidation occurs and at cathode reduction occurs. So what is oxidation? Okay, oxidation is loss of electron and reduction is gain of electrons. So you can remember it like oil rig. Oxidation is loss, reduction is gain. Okay, so an ox, red cat, and oil rig. Okay, So at anode, oxidation occur. Oxidation is loss of electron. And cathode, reduction occur, and reduction is gain of electron. Clear? Okay. Now let's talk about the electrode potential. So you have understand about electrode and electrolyte. These are the core components of an electrochemical system. And now we are discussing about electrode potential. Electrode potential. Suppose we have a metal, and we place that metal in a solution. We place that metal in a solution which contains its own ion. Suppose we are taking a zinc electrode. Here we take zinc electrode and the solution contains zinc ions as well. So an electrode is dipped in a solution which contains its own ion. Then there develop a charge between the electrode and the solution at the interface of electrode and solution. There develop a potential difference between there develops a potential difference at the interface of electrode and solution. The potential difference is called what? Electrode potential. For example, we have zinc electrode and we kept it in zinc sulfate solution. So we have a common ion, that is zinc 2 plus ion. Zinc show tendency to get oxidized. Zinc show tendency to get oxidized. Oxidation means loss of electron. Oxidation means loss of electron. So the metal, what happens? It loses electron and it gets converted into its ionic form, that is Zn2 plus. Here, the zinc atom present in the electrode is converted into what? Zinc ion and electron. To where the ion goes and to where the electron moves. We have seen the electrode. In electrode, electrons move. Electrons moves and the conduction is due to the movement of electron. So obviously, the electrons remains in the metal electrode. Okay, not here. The electrons remains in what? The metal electrode. And the ion moves in the solution. Okay, ions enters into the solution. So Zn2 plus. So you can see when you closely observe here, this is the electrode and this is the solution part. So as a result, the metal electrode develops a negative charge and the solution develops a positive charge. Right, metal develops a negative charge and the solution develops a positive charge. Thus a potential difference is developed. Right, so the measure of this potential difference is called what? Electrode potential. Since here oxidation is happened, we call it as what? Oxidation potential. We call it as oxidation potential. So you see, when oxidation happens, what will be the charge of the electrode? Negative. Right, when oxidation occurs, the electrode gets negatively charged. Then what happens when reduction occurs? We have an example of copper here. Right, copper generally show the tendency to get reduced. That is, here copper ions are present. Reduction means what? Gain of electron. So copper ions are present and it accepts electron and is converted into copper. From where does the copper gets the electron? The electrons is obtained from the metal. Metal always has a sea of electrons. The electrons are delocalized, not tied to a specific atom. And copper takes this electron from this electron cloud. Okay, the Cu2 plus ions present in the solution takes electron from the electron cloud, not from a particular atom. Okay, so the copper took electron from this metal. So what happened to the metal? It loses electron. So a positive charge is developed. And what happened to the solution? Cu2 plus accepts electron and deposited as copper atom. The atoms remains in the electrode, right? So the atom get deposited on the electrode, which means the positive charge in the solution get reduced. The positive charge reduced means negative ions becomes excess, right? As a result, a negative charge is developed in the solution. So at the metal solution interface, there developed a potential difference. This equilibrium potential difference, that is the measure of this potential difference, is called what? Electrode potential. And here reduction happen, we call it as reduction potential. So you see, when reduction happens, what will be the charge of electrode? Positive. Right. So reduction happens. Here oxidation happens and here reduction happens. Actually, the value of oxidation potential and reduction potential are numerically equal. The numbers will be same. The value of the potential will be same. But since zinc show the tendency to get oxidized, means its reduction potential will be of negative value. Okay, and here copper show a tendency to get reduced, so reduction potential is positive value and oxidation potential will be what? Negative value. Clear? So that is about potential. Okay, now we have seen electrochemical cells are there and electrolytic cells are there. In electrochemical cell, chemical energy is converted into electrical energy, and electrolytic cell, electrical energy is converted into chemical energy. And in both cell, here electrochemical and here electrolytic. Both cell has two electrode, that is anode and cathode. And remember, at anode always oxidation, anox, right? Always oxidation, red cat. At cathode, always reduction. Okay, whether it is electrochemical cell or electrolytic cell, at anode the process occurring is oxidation, and at cathode the process occurring is reduction. And what will be the charge of anode and cathode? Here you can see anode is negatively charged, but here anode is positively charged. How will we remember that? Okay, in electrochemical cell, we have seen the electrode potential, right? So when a metal has a tendency to get oxidized, remember what happened? Oxidation means the atom, okay, the metal loses electron, right? Metal loses electrons, which means the electrons remains in the metal and the ions enter into the solution. So what is the charge of metal when oxidation happens? Negative. So in electrochemical cell, when oxidation happens, the charge is negative. And obviously the charge of cathode will be positive. So the reverse is true for what? Electrolytic cell. Either remember like this, or else you can remember it like in electrolysis. Here electrolysis is happening, right? Electrolysis, suppose this is an NaCl, molten NaCl. So we have Na plus NCl minus ions, and during electrolysis, anion move towards anode and cation move towards cathode. Anion means negatively charged ion, right? Anion move towards anode and cation moves towards cathode. If anion is to be moved towards anode, what will be the charge of anode? Opposite charge, right? Opposite charge attract. So the charge of anode will be positive. Okay, so in electrolytic cell, the charge of anode is positive. So in electrolytic cell, charge of anode is positive. So cathode will be negative, and the reverse is true for electrochemical cell. You can remember like that. Either remember an oxidation happening to a metal electrode and write it for electrochemical cell, and the reverse for electrolytic cell. Or remember for electrolysis, anion move towards anode and cation move towards cathode, and write the same sign. Or simply you can write like that. Okay, so you can remember it like that. So what we have discussed today, we have seen the two core components of electrochemical system, that are electrodes and electrolytes. And electrode, the conduction is due to movement of electron, and electrolyte, the conduction is due to movement of ion. And the two electrodes are anode and cathode. At anode, oxidation occur, and at cathode, reduction occur. Oxidation is loss and reduction is gain. Then we discussed about electrode potential. Okay, an electrode has tendency to get either oxidized or reduced. And the oxidation potential and reduction potential is numerically equal but of opposite sign. Okay, then we have seen two types of cell and the charge of anode and cathode in both cell. At anode, always oxidation, and at cathode, always reduction. And you can remember what the charge of the anode and cathode as well. Hope this is clear to you. If you found this explanation helpful and if you want structured classes and complete NCERT coverage, you can join our course. Details are in the description. Thank you.